Let's go ahead and solve a few differential equations, first order separation of variable problems. And I have some on the right side. I'll probably just work the right side. The answers you'll see on the notebook. On the left side is what I'll do in the video. So let's go ahead and start this one. So it's separation of variables. So we'll have dy dx equals negative e to the x over 8. So actually there's no y to move over to the left side. So I'm just going to multiply the dx to the other side to get negative e to the x over 8 dx. And I should have introduced, remember, this is a separation of variables problem. As long as your y is a multiple to the x, like if you can somehow separate the y by dividing, not adding or subtracting, but by dividing, then it's a separation of variables problem. And really, all of these will be separable. Over here, we'll talk about in the next video what's separable and not separable. So let's go ahead and integrate both sides now. And the integral of nothing in respect to y is just going to become y. Because think about that. Derivative of y would just be 1. Derivative of y in respect to y would just be 1. Then over here, that's negative 1/8. It's just a constant out in the front. And the integral e to the x is e to the x. That just becomes e to the negative e to the x over 8. And then don't forget plus c. So actually, this is quite an easy integral. And I guess I could go through the steps of that integral, pulling out that negative 1/8 to the front. So you can see that's just e to the x. So it matches one of those nice integral formulas that we do know. So then negative 1 over 8 e to the x. And then plus c is a big deal when we get to differential equations. And there you go. So that's the first one. Easy because there's nothing to move over as far as y is concerned. The next one there is though. So let's go ahead and solve this one. So I'm going to go ahead and divide this y to the negative 1 to the other side. And so I will have 1 over y to the negative 1 dy, and then I'll multiply that dx to the other side. Now I don't want that y in the denominator, so I'm going to bring it up to the numerator. So it just becomes y dy equals x to the negative 3 dx. And let's go ahead and integrate now. If I can draw these. So the antiderivative of y is going to become y squared over 2 equals, and then we'll have x to the negative 2 over negative 2 plus c. And so hopefully you kind of watched the video before this as an introduction. We already talked about a few of these things. So let me go ahead and give myself some more space here before we continue solving. So we need to get y by itself. So I'm going to go ahead and multiply the 2 to the other side. So I'll have negative 1 over x squared. We'll put that on the bottom, plus c. So let's stop and talk about this for a little bit. What happened here? If I could draw my x. So what happened here is I multiplied the 2. So the 2 and the 2 canceled there. Then 2 times c is just c. C is just some random constant. We don't know what it is. We're going to solve for it later. So it doesn't really matter if we put the 2 there or not. So by habit, we've learned just not to put the 2 there. And we'll solve for it later. It doesn't really make a difference if you did put 2c or if you just leave it as regular c. But, you know, a little more formal with math, usually they just leave it as c. And then the x to the negative 2 I just brought to the denominator because it's a negative exponent. So let's go ahead and square root both sides to get y by itself. That's where plus or minus comes in at. Now, I was saying earlier, like square root of c is just c. Yeah, I'll agree with that. But the square root of 1 plus c, we can't separate those because there's addition going on. If it was multiplication, like square root of 5 times c, then that would be c squared root of 5. The square root of c wouldn't affect c, but because there's a plus, we can't do that. Remember, you can't separate those as two separate things. It's different in multiplication. 5 times c could be separated as square root of 5 times square root of c, and square root of c is just c. And that's the reason why we can bring that c out to the square root in that case. But because of the plus, we can't do that. And so we'll just leave it inside like you see there. I think part of my problem is my writing's getting smaller. I just like start large and then it just gets down to a smaller writing and it just makes it look worse and worse, right? Oh well. Make it better on this one, right? Okay, this one's not so obvious as to what we can divide. It's not like we can just straight up divide y, because there's two of them here. And this is actually a mistake I made in college, and it was really sad because it caused me to get a bad grade on one of my tests. Just this one little mistake here, actually. It was this very same mistake. So let me show you what to do. We can make this a situation where we can divide our y. So how am I going to do that? Well, I see if there's a y in both of these. So let me just go ahead and factor it out. So I factored the y in common. Think about that. If I distribute the y back, we end up right back to here. So I factored the y out that's in common. Let me go ahead and divide the y over. And multiply the dx over. Now we integrate. And this is a little more of your classic the separable problem, or separation differential equations problem, because integral of 1 over y becomes natural log of y. This will become 2x to the 4th, because we add 1 to the exponent is 4, divided by 4. 8 divided by 4 is 2. Minus 4x squared, similar reasoning there, plus c. Now we're going to raise each side with a base of e. Cancels out, gives us e, or y equals. So why did I do that? E and natural log are inverses of each other, so they cancel each other out, leaving us with just y. And then what we'll have on the right side is going to be e to the 2x to the 4th minus 4x squared plus c. All that's in the exponent. Now let's talk about something, and I talked about it in the previous video. You'll see for the second problem here, if you want to refer to that same exact explanation, I'll just go ahead and give it again. So if you have two numbers like x squared times x cubed, what do you do to the exponent if you're multiplying numbers of the same base? You add the exponents, right? Similarly, we can separate those. If we had x to the 5th, I could separate it out as like x to the 4th times x to the 1. Any way I want to separate that out, as long as the exponents add to 5. So I'm going to do something similar here. I'm going to take this and write it as e to the 2x to the 4th times e to the negative 4x squared times e to the c. And then e to the c is just c, so this becomes e to the 2x to the 4th times e to the negative 4x squared times c. So just kind of bring that c to the front, and then we'll go ahead and go back to adding those exponents. Really common way you're going to see this situation, they don't leave c in the exponent most of the time. They bring it down, and that's the reasoning behind it. You can separate it out like this, then e to the c, since it's just a constant, e to the c just becomes c. You know, just like 2 times c is c, like we saw earlier, we didn't put the 2c, we just left it as c.